Experiment number 4. And you guys, you're going to like this one. Of course, land with its mountains and valleys is not perfectly level, as is water. However, when large expansive areas of land are considered, it can be determined that land is not convex, as would be expected on a spherical Earth. Land is generally flat, and scientific research proves that fact. Take, for example, Mark Fonstad, Ph.D., William Pugach, and Brandon Vaught, Ph.D. Use data from the United States Geological Survey to determine that, on scale, the state of Kansas is literally flatter than a pancake. The researchers used what is referred to as the flattening ratio to compare Kansas to a pancake. The flattening ratio is as follows. F equals A minus B divided by A. So what that means is the length of the area is measured, which would be A. The height of the area, which is B, is subtracted from the length. B is subtracted from A. And then the figure is then divided by A. So height is subtracted from area, and the result of that subtraction is then divided by the area. And that equation is where you will find your flattening ratio. If the area is perfectly flat, the result should be 1, or 1.00000, on a scale where 1 is perfectly flat. The geographers used a confocal laser to determine that a pancake had a flatness of 0.957. So this flattening ratio was used on the pancake. The state of Kansas was scaled down using a 1 to 250,000 scale digital elevation model, and Kansas was found to have a measured flatness of 0.9997. That means that Kansas is literally flatter than a pancake. Jerome Dobson, president of the American Geographical Society, I just love this part, professor in geography at the University of Kansas, and Joshua Campbell, geographer and GIS architect in the Office of the Geographer and Global Issues at the U.S. Department of State, came to the defense of the state of Kansas. They didn't want people to think that Kansas was flat and boring. Dobson and Campbell used a different measure. Instead of the flattening ratio used by Fonstad, Dobson and Campbell used a simpler equation that we will call a relief quotient to analyze the research study of Dr. Fonstad. The pancake used by Fonstad was obtained from an IHOP restaurant. Its relief was measured over a 2mm sample strip taken from across the 130mm diameter of the pancake. Relief means the quantitative measurement of vertical elevation change in a landscape over a given area. For an area of land, the relief can be obtained by subtracting its highest point in elevation from its lowest point. So the highest point in the state of Kansas is 4,039 feet above sea level, and the lowest point is 679 feet above sea level. Now, if we add those two figures together, we arrive at 4,718 feet, or 0.89 miles. The relief for Kansas, therefore, is 4,718 feet. The east to west transection of Kansas is approximately 400 miles across, resulting in an approximate relief quotient of 0.0022. So, 0.89 miles divided by 400. So from east to west, Kansas is 400 miles across. And then if we add 4,039, which is the feet that is above the sea level, to the lowest point, which is 679, we arrive at 4,718 feet, which is the equivalent of 0.89 miles. So if we divide 0.89 by 400 miles east to west, we arrive at 0.0022, okay? So that is the relief quotient. Dobson and Campbell accepted the results of Fonstad's study as accurate, surprised to find that the relief quotient comparison revealed that every state in the United States is flatter than a pancake. The pancake measured in the article was 130 millimeters, and its surface relief was 2 millimeters. So, we apply that ratio to the east-west dimensions of Kansas, which is approximately 644 kilometers, or 400 miles. And the state would need a mountain of 9,908 meters tall in order to not be flatter than a pancake. But since the highest mountain in the world is 8,848 meters tall, every state in the United States is flatter than a pancake! Furthermore, the larger the landmass, the greater is the arc that would be expected in a hypothesized spherical Earth. That means that Florida, which was determined by Dobson and Campbell to be flatter than Kansas, could only be flatter than Kansas if the Earth was flat. And Florida is 447 miles across from north to south, compared to Kansas at only 400 miles at its longest form from east to west. If the Earth were a sphere, that would give Florida a bulging arc of 33,153 feet and a relief quotient of 0.014 over its 447 mile length. That means that if the Earth were a globe, Kansas would, with a globular relief quotient of 0.0125 on a supposed globular Earth, would be flatter than Florida. But in actuality, we find that Florida is flatter than Kansas, which would be impossible on a spherical Earth because Florida is larger than Kansas. Indeed, Florida is the flattest state in the United States. Indeed, when the relief quotient calculations are applied across a larger expanse of land for thousands of miles, the difference in relief quotients between the figures for a globular hypothesis and the actual relief quotients are stark. The larger the expanse measured, the lower the relief quotient. That could only happen on a flat Earth. For example, the continental United States is approximately 2,800 miles across. If the Earth were a globe, the continental United States would have a terrain with a bulged arc approximately 1,306,666 feet. That's a lot of sixes. Above sea level across it. No such topological bulge exists. The highest point in the continental United States is 14,494 feet above sea level, and the lowest point is 282 feet below sea level. So the relief across the 2,800 mile breadth of the continental United States is therefore 14,776 feet, or 2.8 miles. So if we take the 14,494 feet that is above the sea level, and we add it to 282 feet, which is below the sea level, we get a number of 14,776 feet. So you take that 14,706 feet equals 2.8 miles. So dividing the 2.8 miles by the 2,800 mile breadth of the continental United States gives us a relief quotient of 0.001. The actual relief quotient for the United States of 0.001 means that the Earth cannot be a sphere. So using a pancake as a gauge of flatness, we find that the terrain of the continental United States is, on scale, significantly flatter than a pancake. Sorry, got a little excited there. The relief quotient of a pancake is approximately 0.043, which is exponentially greater than the 0.001 relief quotient of the United States. Dr. Dobson performed additional research on the issue of the flatness of Kansas, and Dr. Dobson was joined in his research by Joshua Campbell. Dobson and Campbell used a different methodology than did Dr. Fonstad et al., but their research confirmed the results of Dr. Fonstad et al. Most notably, Dobson and Campbell found that the entire United States was flatter than a pancake! Dobson and Campbell further discovered that Florida, Illinois, North Dakota, Louisiana, Minnesota, and Delaware were all flatter than Kansas. Dr. Dobson extrapolated from his own confirmatory research that the entire world is flatter than a pancake. Dr. Dobson had this to say about the research study by Dr. Fonstead et al. Our own findings did not refute their conclusion about Kansas, but rather proved that their conclusion applies to the whole world. Dr. Dobson's research was published in the Geographical Review, a peer-reviewed journal published by the American Geographical Society. Neither Dobson and Campbell's findings nor those of Dr. Fonstead et al. Have ever been refuted or even challenged. Wow!